Palmer from CommScope here for the first time. We're going to talk about Wi-Fi 7 and the Ruckus R770. So, Jim, I got one of the first R770s. I think I put a post on LinkedIn and it got like 3,000 likes like immediately, and then I saw Ruckus Networks reposted it too. So they must be excited.
Yeah, I mean, let's be honest. You have one and I don't, so that's, I'm not quite sure what that says about either one of us. But
yeah, I had to jump on it. I get too excited for this stuff, right? So I was like, oh yeah, they have it. My local Ruckus rep Rudy told me that distribution was getting them. I was at a event down there in Connecticut. He said the distribution is getting next week, so I'm like, I got right on it. I probably got the first one out the door.
yeah, probably. But yeah, it's an exciting time.
So some of the requirements on the R770, it needs to be on the R1 cloud to get full functionality, right? Like I had some people asking, I know about the 760, and they're a little confused. Some of them, they buy it and they wouldn't realize they need the cloud, right?
Yeah, so right now the R770 you need Ruckus One to run it. But that's just right now. In the future, it will be supported on the Smart Zone platform as well as on Leashed. But that's going to be rolling out. I don't want to put any dates out there and then have engineering tell me I'm wrong. But it's going to be coming the first half of this year at least. I'm always leery to put dates on things because we'll just go with AFC there for a second, and then people understand.
Yeah, and I guess this was the first time that they rolled out to the cloud first, right?
Yeah, and part of that has to do with how Ruckus One was redesigned. We did I did a podcast last year, and we were talking about Ruckus One, and we called it an evolution. Going from what Ruckus Cloud to Ruckus One. And I think a lot of people think that what we did was just simply take Ruckus Cloud, add a couple bells and whistles, and then, added a new UI and it said, hey, look at this new shiny. And that's actually not what happened. The engineers went back into the labs and they developed this thing from the ground up, and they rebuilt the entire back-end infrastructure of the cloud platform. And so Ruckus One, it was really designed and engineered to be able to be super flexible and to be able to adapt to the changing technology, because as you and I both know, technology changes super fast these days. I mean, I tell people all the time, I can barely keep up anymore, and it's my job. I feel bad for people who are like, oh, I actually have to do something else and keep up with technology. But it was done with the idea that when these new things come out, Ruckus One could be the very first one, because it's a very simple evolution to be like, oh, this is the next thing, so we can put it on there. And it was built specifically to handle, the R770 coming out, and being first to market, from an enterprise standpoint. There was some consumer stuff, but it was built to handle stuff like that. So it wasn't an accident, and it was by design that Ruckus One is the platform right now that was able to support the R770.
Yeah, I think as soon as I got this access point, I went ahead and added it to the cloud, and there was immediately a firmware update. I updated the firmware, and then on my cloud I could see 320 megahertz and multi-link. I could pick which band I wanted, to use for multi-link, right? Two bands.
Yeah.
And that's the first step, right? 2 bands, and then eventually could go 3, or?
Well, it's a preference thing.
Yeah.
Right. So and I talked about it at an event last year called Mobility Field Day, and that video's on YouTube. You can go find it. Mm-hmm. And what the Ruckus engineers learned when they were developing the multi-link operation, for those who don't know, multi-link operation is the idea that your phone or laptop, your client device, will be able to talk on 2 different bands. And there's a couple different modes of operation of having those 2 different bands in operation. Now, one of the things they learned was we actually, in order to get those 2 radios to work at the same time in the same device, whether it's an AP or a client device, there has to be some RF isolation that happens, because even though you're in different bands, if you have transmitters and they're really close together, they can actually jam each other just at the highest level, right?
Mm-hmm.
Or the lowest level, I guess, just the most basic level, just at the RF level, they will jam each other, even if they're way off frequency. And so they have to add some isolation in there, and that costs 3 dB of of isolation, from your transmit powers and your receive in order to make that happen. But then on the other side, like the AP is a tri-band. It literally has 3 different radios, right? Your phones only have 2, and they switch between which bands. And so right now you can pick, and the default is 6 gigahertz and 2.4 to give us enough separation that we can actually tune down the 3 dB loss to something's a little bit better. But you can actually enable 5 and 6 gigahertz, but you then take a penalty on, because in Wi-Fi, we never get anything for free.
Yeah.
There's whether you pay for it in dollars, or you pay for it in performance, or you pay for it in power. Now your switches need to have a lot more power to run the 3 radios.
You gotta have
that. I feel like we're finally at the point you have to have multi-gig if you're going to deploy a true tri-band 2.4, 5, and 6 gigahertz. So you're going to pay for technology, and Wi-Fi is the same way. So it can do it, but I don't think we're ever going to get to the point where you, especially in phones, where you'll be able to run like all 3 bands simultaneously, because the power draw on your especially your phone is going to be enormous. And people are always complaining about, my phone battery doesn't last throughout the day. And that's with a lot of things being done to save battery.
Yeah.
Can you imagine if we said, your Wi-Fi is now going to run 3 radios simultaneously?
3 radios, yeah, exactly. Well, so I did choose, when I did my testing, I'm like, I'm switching to 5 and 6. I want to see the maximum throughput, right? So I have this little Osmium Clarity Spectrum Analyzer here. And I'll put up the slides, but you can see when I did like some speed tests, that you could see the 5 gig and the 6 gig. I'll put them overlaid here a little bit, but you could see the 320 megahertz 6 gig channel, and then I think it did an 80 megahertz 5 gig channel. So I could see that on the Spectrum Analyzer, which is nice. And then in Windows, once you get the latest version, you gotta have the preview right now, okay? Because it adds in all the great features, but you can see in Windows that you have an aggregate. I'm putting up the version I have here, and then you'll see that you have an aggregate connection. So it'll actually say there aggregated connection. So that way okay.
Yeah, and not only do you have to have the latest Windows, you also have to have the latest, little card inside your Windows.
Oh, you haven't put it in.
And you have to have the latest, or not the latest, but you have to have a very recent processor and core in there, in order to run it. So it's right now it really feels like it's one of those things where you have to stand on one leg and hold up your left hand and put your right hand over here, and then to be able to get it.
I was actually surprised I could get that BE200, that's the Intel adapter we're talking about, installed in there and working, because I think I have a 10th generation Intel, but it does have to be Intel. I had people saying, I have an AMD, and why can't I use it? I don't know. It just doesn't work. It's an Intel chip, right?
It is, and it's because it's the Intel BE200, so it's just and as we were talking about before we went live, it's also about the client drivers. I can't tell you how many times especially like AX, when 802.11ax Wi-Fi 6 came out.
Yeah,
I kept seeing a lot of people talking about how they would enable Wi-Fi 6 on their networks, and like half their Windows laptops would just give them fits. And it turned out that they had to update the actual driver firmware in the laptop, and in order to be able to even enable 802.11ax without crashing half their devices. So the client drivers is always a fun thing to chase from the Wi-Fi professionals standpoint.
Yeah, I actually posted the 6E drivers on my website, and I can see people are downloading them today still, because the certain version that worked, right?
That's it, and that's part of the fun of, especially like you've been learning with the R770 and Wi-Fi 7. It's always the fun of a new generation of Wi-Fi, is trying to make sure that hey, the AP over here and the client that's over here have the drivers and everything to work together because, unfortunately, there's just so many different clients. I was at a conference last year, and somebody was saying that there's like 1,500 different devices now that do 6 gigahertz, and that's 6E.
Yeah.
But it's like there's 1,500 devices, and I tell people all the time, I'm like, I only have so much room in my lab, and I can't have 1,600 different devices to test to make sure they all work. So
yeah, I mean, the big thing is iPhone now supports 6 gigahertz, so that means we're going to see a huge rollout, and everyone's going to be asking for 6 gigahertz support eventually.
But it's been a really funny timeline, right? Because you're right. So the iPhone 15 came out. They announced it in September, started shipping in October of last year, so 3 to 4 months ago. And so now, unfortunately, you're then at the end of the year. So now people were started talking about, hey, now we need to support the 6 gigahertz. Now it's something we're really going to focus on. But at the same time, it's like now we have Wi-Fi 7. So what do you do? And I can't answer that question. I don't know.
Yeah.
I tell people all the time, I can't answer that question because I don't know your specifics.
Right. I mean, I think, yeah, there's a price penalty, but at some point it's going to be mainstream. You know what I mean? Like, and you're going to have to do it. And I think, as we know, when that new iPhone rolls out, eventually everyone's going to get one. I mean, there's going to be millions of 6 gigahertz capable devices out there if there aren't already. So that's big. But let's talk about some of the speeds that I saw. See what you think here. So I started using open speed test. I always used iPerf, and I have a 1.4 gigabit internet connection. I would do that, and that was hard to saturate before 6E, right? So that was usually good enough, right? I'm like, here, everyone knows speed test, but the open speed test looks pretty good. I'm not. Do you know about it? How it actually works? Is it using iPerf?
I don't believe it is, but I don't know enough to to act. I don't want to say anything that then comes back and be wrong. So
yeah, I'm not sure. I didn't look into it exactly, like what it's using, like because with iPerf you have to do maybe 8 streams to saturate. You have to get the settings just right to get a good number, but. I was able to get, if I can get this slide moved over, let me see here. There we go. Is that it? I don't want to jinx anything here, but I saw about 2.7 gig on the upload and 1.7 gig on the download. So that's with 6 gigahertz and 5 gigahertz and pretty close by. Okay, so that's pretty good. That's better than we've seen with 6E, which was, I would say, what were we getting with 6E? With maybe we're getting about 14, something like that, 1.4.
Yeah, and part of it has to do with the new QAM. If you're especially in sort of a lab environment, where you can run that 320 megahertz wide channel, and you have the 4K QAM, the 4096 QAM, and you can make that happen. If earlier you turn to the side and you're like, yeah, there's the AP right there, right behind you. Yeah, it's right there. So you get this really high RSSI value, so you're close. If you have a low noise floor, then you get a really high SNR, so you can get that 4096 QAM on a 320 megahertz wide channel. We can really now push, more than 1 gig. And so, that's been a conversation for many years, and I mentioned it earlier about paying for a switch that will now support your tri-band AP, because if you're doing, before it'd be like, oh, we can almost get to 1.4.
Right.
And it's like, but that's in a lab. And when you put that in the real world, you never drag racing the school bus is not something that happens every day, all day. But now, as you're alluding to, you're talking about, we're now getting some really, if you're getting 2.2, and on that, and we haven't even talked about other stuff going on. So now you're to the point where, hey, we might actually need to be, over 1 gigabit on your uplink from the AP to the switch. So it's, yeah.
Yeah, I have. I do have a multi-gig PoE++ switch here, and I was testing on that, and I'm like, hey, I got a couple 10 gig ports. Let's put on 10 gig, and I put it on a DC power supply, and I was able to. I think I was able to see a little bit more. So that's a single client that I'm, hitting 2.7 gigs. So definitely have to be multi-gig switches at this point if you want to take advantage of it, and you're going to need it for the power anyway.
Yeah.
Right.
Yeah. And the other thing is, it's not just for a lab, it's cool. It's like, hey, I need PoE plus or but it's 802.3 BT class 5 for the super nerdies,
Yes.
which means you need 60 watts, right? But it's not just, and for a lab, it's like, okay, as long as I have one port that can do it, I'll be fine. But the problem you run into is in a bigger deployment, now it's I need 60 watts per port, and I might have 4 or 5 APs plugged into this switch. And now all of a sudden it's about what is the overall switch PoE budget. And that's something I've really been harping on over the past 6 months or so, as we've been talking about Wi-Fi 7 coming, is, hey, it's not just about the raw speed, and that uplink. It's also the power that you're going to need per port. And then, and I tell people all the time, I'm like, if you're running, say 802.11ac Wi-Fi 5, and you're upgrading to Wi-Fi 7, and you have switches that have a total PoE budget of
140 watts or something,
or 270 watts, and you're like, I'm going to plug 5 APs into that, and you're going to Wi-Fi, you plug it in R770, it's going to max out, and then now you can't even get them all running at the same time. So it's a whole generation. We talk about 6 gigahertz sort of reinventing Wi-Fi, but now that we're actually going into the Wi-Fi 7, and as we go forward, all of the Wi-Fi standards are going to include 6 gigahertz. So we have to, so this is really a tipping point when you're talking about upgrading, because 6E only came out 2 years ago.
Yeah. So I know there's a new Z series switch coming out, right? A small one, maybe.
The 8200.
Yeah.
C08 ZP.
Okay. And how big is that? How many ports is that?
That's 8 ports.
Oh, it's 8. So it's replacing like the little 7150 I have over here, maybe. Yeah.
So there was a 7150C.
You can't see it.
Yeah. There's a 7150 C12. There was a C10 ZP, and then there was a C8 that was hardened. And I don't remember the
I have a C12P, but it's not. That's not what I'm plugged into. I'm plugged into another multi-gig PoE++ switch from a Genius, so we know it actually works with other switches too. So all right, so we talked a little bit about specifications and requirements. So PoE++ 60 watt for full functionality or DC power supply, but it will run on other PoE standards, right? At diminished capacity. Yeah.
Yeah, and if you look at the spec sheet, which I don't have pulled up, but it's actually something I've been really pushing with with our product team, because I came from a customer side before I started working for Ruckus. So I was the guy sitting in his cubicle at a corporate office, looking through spec sheets, and so it's something that I push for. That now when you look at our spec sheets, it's very clearly detailed. Hey, if you have full power, then you get full functionality. But if you're only running this much power, this is what you lose. And usually the first thing that goes is the USB port, or the IoT radio, and the IoT radio. But you can now go look at the spec sheets, and you can really see, and they've done a really good job. So I have to give them credit, because now it makes me happy, because now I can go look at a spec sheet and go, okay, if I'm plugging into a 30 watt port, what exactly am I going to get, and can I afford to lose that? Yes. Okay, then I'm fine.
Right.
But
and that's kind of part of the sales process, is you have to inform the customer that, hey, they're buying this new AP, but if your switch and power doesn't match up, you're not going to see the best results. One last thing about the testing, you talked about the distance. So I'm maybe like 8 or 10 feet away from the AP. But I noticed when if I put the laptop on top of this table, which is maybe like 3 feet away, I was going up. I actually saw faster speeds. I know that's not gonna with 6 gigahertz and Wi-Fi 7 in particular. I never saw that before. So that was interesting, kind of.
you've opened up a can of worms, and I'm not sure that you have the time for this.
Well, I don't want to. We don't have to talk about too much, but what I can say is going that close never improved throughput before, but now I saw like five. I saw right now where it's sitting. I'm seeing like 3.8 gig. When I put it over there, I saw 5 point something. So.
And there's some physics behind that if you really wanted to get into, we can get into. But generally speaking, what I tell people though is you do, and people are always like, I'm going to get my device so close to the AP,
right on top.
And yet it actually makes it worse when you do that.
Yeah,
I never recommend that.
Right.
Unless you do exactly what you did, right? Because now you have a little bit of separation, and you're actually sitting in what's known as a null of the RF stuff. So if you were to take that laptop and say put it over next to your printer there, you would see a totally different experience, because now you're no longer in the null to where the RF signal is actually a little bit lower, because you can, if you get it too close, you can actually oversaturate the receivers. Because you have to think about it, right? The receivers are tuned to where they're listening to something down to like at least a neg 82, right? Because that's where we're do clear channel assessments, and most devices now can go down to a neg 90, which is a very low signal. So they're tuned to listen to that and to be able to decode it. But when you put it right next to the AP that's doing a plus 20 or a plus 10, you're now talking about 100 dB from where they're tuned to listen to what you're now jamming into the receiver. And so you can end up with, it's like going to a concert and you're like, I'm going to go stand right in front of the big giant stack of speakers because that's where I'm going to get the best sound. Right? Yeah. And then you spend 5 minutes there and you're like, wow, this song sounds like garbage. I can't hear anything. And then you walk away, your ears are ringing, and you can't. And you realize as you back away from that speaker stack, you're like, wow, it actually is a little bit better if I'm not right up next to it.
Right.
And radio works the exact same way because it's still a wave, right?
Yeah.
It's just at a different frequency. So, yeah, that's just if you look over here, I have a bunch of radios. I play with radios a lot.
Yeah, I can see that. Yeah, I have one of those. What are they? Bang Fung.
Baofungs.
Baofungs. Yeah, they're pretty interesting. Pretty cool product.
Yeah, that's the three little ones in the middle. Those are Baofungs, and then I got the one on the end. That's an ICOM air to ground, and then I have some other ICOMs, and I think I got rid of my other ones.
I only listen to them. I'm not licensed, so don't tell anybody.
Listening is fine.
Yeah.
I'm licensed. I'm licensed.
Yeah.
I'm licensed pretty much with everything. I have an amateur and a commercial radio license.
Nice.
So I have both sides of the fence, but I only listen because, quite honestly, if I'm going to talk to somebody, I like making it work, and then once it works, I'm like, I get bored with it. I'm like, I don't want to talk to people.
It is cool, the channel programming and everything with the cable. They really stepped it up from the old days, I think. So one last thing before I let you go, let's talk about the smartphones. Like, so there are a bunch of smartphones. They're advertising they have Wi-Fi 7 capability, right? Like the Pixel 8. Is that a Pixel 8?
This is a Pixel 8.
Okay, so you're the pro on that. So that they advertise it has Wi-Fi 7, but what's the problem with that?
So what we're hearing is right now it doesn't support 320 megahertz. We were doing some testing, and as one of the first to market with the Wi-Fi 7, we've been able to work with some of the device manufacturers, and that's something that we learned in our testing. And so it's something that Google is working on, but it's and we were talking about this earlier.
Yeah.
The client drivers and getting all this stuff to work, especially when it first comes to market, there's a reason why it's called the bleeding edge, and it's like, oh, I have to be part of this insider group to get the Windows drivers, to get this, to make all this stuff work. There's a lot of stuff that has to happen when we first announce any of these new standards, and you were talking about Apple, and when they roll out a new iOS, how soon between when they roll it out and you get that first patch, it's like, and most people know it's like, if you're going to download and install the latest iOS, the day they launch it, you're going to have to do it again in probably about 3 or 4 days.
Yeah, for sure.
So being the bleeding edge is cool, and you get some advantages to it, but you also have to understand that there's also a bleeding edge, and there's a reason why they call it a bleeding edge, and there's some disadvantages. So you could be on the cutting edge, but man, when you get to that bleeding edge, you really feel that pain sometimes. So that is one of the limitations of that.
Yeah, yeah. So, but you'll still see great results on 6 gigahertz with any of these phones. You'll see over a gig. So
Yeah,
that's really good, and you're using that clean spectrum, right? So it's like it's more reliable if you have a mission critical application, for sure.
it's more reliable because there's not as many devices, and we have so much more spectrum, especially in the U.S.
Yeah.
In the U.S., when we talk about we have 1,200 megahertz worth of spectrum. Whereas in 5 gigahertz, I think we have 580.
Mm-hmm.
And that's I think and then we have that whole big giant chunk, that we don't even have access to. And so you can't even run a 320 megahertz wide channel in 5 gigahertz. And you shouldn't.
No. And you probably shouldn't at 6 gigahertz either. Now, this is just for testing to see these crazy numbers, right? Like, we're not going to want to really do that. Maybe.
It depends, right? Because look, it always depends. And there's a gentleman that I took a class from, and it was actually the Certified Wireless Design Professional class from CWMP. And the guy that was teaching it, he said, here's my mantra, and he's designed a ton of networks. He said, you go as wide as you can until you can't.
Okay.
So it's all about, I mean, we have the spectrum. We don't pay for it. You're not going to get a refund for not using it.
Mm-hmm.
So if you do a design, if you're looking at it and you're like, hey, I have this 40 megahertz of spectrum over here that nobody's using, and it's like, can I actually go to a wider channel? And now 160s I wouldn't recommend, but there are times I have done networks where I've done some 80s, because if you use Uni 2, you can get 5 channels at 80 megahertz wide. So it's like, why not use it? And so it's always it depends. We need to take a look. We need to do some more investigation. We need to figure out. And right now, especially with low power indoor 6 gigahertz and how much attenuation that we're seeing. You put the AP up, and if you play with 6 gigahertz, and I did this at my house, I took an R570 and I put it in my upstairs, and I was looking at it downstairs in my office, and I was like, wow, I can barely see the 6 gigahertz network. Even just to see it, you see the beacon, let alone try to connect and use it. And it's like, but when I look at the 5 gigahertz radio off of that same AP, it'd be like, man, it's so much higher, and I could connect to it and I could use it. And so we have this additional attenuation based on, it's just how the frequency behaves when it passes through walls and other obstructions and other stuff, and it attenuates a little bit more. And so we're seeing these smaller cells because of that. And so it's one of those things that I keep telling people. I'm like, when 6 gigahertz really is a whole big thing, and if you're going to do it, take some time to do a proper design using a good tool, and figure out, hey, if I have enough isolation between my two APs, I could run 160s.
Possibly. Yeah, I mean, I'm seeing
possibly.
And plus you would like with the R1 Cloud, everything's coordinated, so it's going to know what channels, as long as you have your own one network in your building, it's going to know what channels are being used. It's going to make sure they're not overlapping, so it's going to do that smart thing. But yeah, I've noticed about 30% reduction in range with 6 gigahertz, maybe 25, something like that. But when you said you only had like maybe one bar downstairs, if you connected to that, it's also pretty reliable. Like I actually would see 5 gigahertz with full bars, 6 with one bar, and I have a better connection on that. On the 6 gigahertz.
Well, it comes down to two things, right? Channel bandwidth. Client devices will prefer a wider channel bandwidth, because even at a lower signal level, you're still going to get more throughput, because you say you're getting an MCS 2, MCS 3, right? And it's on a 160 megahertz wide channel with nobody else on it, right? So you're going to get much better throughput performance at that than if you're on, say, around my house, if you're on Uni 1 or Uni 3 and you're only running 80 megahertz wide, it's even though you can have a higher MCS rate, because you have that higher RSSI, the noise floor is a little bit higher, and it's so congested that the performance is not going to be as great.
Yeah.
And so there's some other factors that go into it, and that's why we're seeing the performance and seeing all that stuff on 6 gigahertz. I mean, when I look at my neighborhood, and I'm in a suburban area, and I have tons of houses around me, I can see 40 different networks, right? 25 of them are on Uni 1, and 20 of them are on Uni 3, and they're just saturated. And so you don't get a great performance. But then if you go, oh, here's this really lower signal on 160 megahertz wide channel, then yeah, you're going to get some, because nobody else is there. I cannot see another 6 gigahertz network in my neighborhood, even though I can see 40 5 gigahertz networks that aren't mine.
Right.
So that really starts playing into why devices will do that. And I was doing some testing last year where I found out that, it really, client devices are now getting smarter. You were talking about MLO, and link aggregation is the mode you were talking about. There's another mode in Wi-Fi 7 MLO that I'm really excited about, which is called link selection. Because what it does is the client is now in real time looking at the 3 possible links that it could use across the 3 bands, and it's picking which one is the best, which tells me that client devices are now starting to pay attention to the stuff that we've always been paying attention to. And they're going to pick which link is the best, because it's all about getting my data through the first time. I don't want retries.
Right.
And so link selection part of MLO, where it'll be like, I'm just going to switch at will instead of sticking on one radio, and I'm going to be like, I'm going to hammer this one. If it sees that 6 gigahertz is better, it'll switch over there. If something happens at 6 gigahertz and it's like, wow, I can get it better on 5, it'll switch back. And that's something that I'm really excited about, is the idea that, hey, our clients are now starting to pay attention to stuff and going, yes, it's not just about raw power. I can connect to an AP that has on 5 gigahertz that has great RSSI, but it also has 50 clients and 5 different APs with co-channel interference, and so my performance is going to be garbage. But I got a really strong signal.
11B clients on there too, maybe. Internet of Things devices.
Well, not at 5 gigahertz, but
not 5.
It's the same, right?
Is
now it's the devices, the client devices are getting smarter and taking a look and saying, hey, where do I actually get my best performance? Not just who's yelling the loudest.
Yeah.
And in the past, it was always about who's yelling the loudest. So
for sure,
it'd be nice if we could just go, oh yeah, it's just one thing, but it's not.
It's not. There's a lot. All right, Jim. Well, this has been great. Anything else you want to talk about today?
Oh, we could talk about all kinds of things, but I'm not sure anybody wants to hear it.
We could be here all day, because this is exciting to us. I can tell. But the R770s are in the channel now, so anyone that wants one, order one, give me a call. Give Jim a call. I don't know if you actually talk to your sales guys. They're available and they're working. All right, remember, like and subscribe, and we'll